All right, so at the end of the video on determinants, I left you with a little puzzle. Explain, in just one sentence, why the determinant of the product of two matrices is the product of their determinants. First off, if you haven't done this already, I highly encourage you to work this out with a set of example matrices with some numbers put into them. What you'll find is that numerically, this is a really surprising fact, with a lot of different moving parts that have the feeling of just happening to fall together quite nicely. And this is such a good example of how a visual intuition can clarify what's really going on under a simpler light, exposing why the computations fall together so nicely this way. Okay, you ready? One sentence explanation. Here we go. Well, okay, really I'll do it in 3 for clarity, but you could cram this down to one sentence if you really wanted to. So if you scale an area by some factor and then scale it again by some other factor, the overall effect is just to scale it by the product of those factors, right? And if you apply the matrix M2 to a space, and then follow that with the action of the matrix M1 on that space, the overall effect is, definitionally, the effect of applying the action of their product matrix, M1 times M2. Well, the action of M2 scales areas, or volumes, by the determinant of that matrix, and the action of M1 scales areas, or volumes, by the determinant of that matrix. So the factor by which the composition, M1 times M2, scales areas or volumes, which is what the expression determinant M1 times M2 means, well, that's going to equal the product determinant M1 times determinant M2.